Normally this graph, these current scatter plots would at most get 3 out of 5 if I was actually marking them. They're missing X, Y axis label. Equation and R value is good, but the format's horrible, all those kind of things. But it's enough to be able to see the difference. What I like about this and having them side by side, as I change this, I want you to look at the graph, but also look at the R values that are down here that hopefully you can see. I think the easiest way, and when you get into your ISU or other spreadsheet work, you'll do this a fair bit. You have the data set right now. All I've done is killed the outlier, and then immediately I can see that both R values are 0.63, so that's a strong positive linear correlation. My graph shows that they're the same. And then as soon as I hit undo, what it does is go back and adjust this and take that one value out. Let me just put it back in here. Takes that one outlier and puts it back in. And then you can see how it greatly decreases the R value. So this is the most classic example of outlier effect. Take the outlier out, the R value goes up. What you have as a moderate relationship looks like a less strong relationship over here, but really it's just because that one value is messing it up. So I hope that's straightforward. Speaking with the yearbook example I just did, Emma and Chris, Rory, if either of you are interested in doing that kind of thing, you would not do a lot of scatter plots for a yearbook because most people don't want to look at that kind of graph. But if you had something that was good to do across the grades, this would be a really important example where you pull out a couple of outliers, you just don't include them in the graph. If there's some students that just completely messed up the answer, faked it, you can just tell they're lying because they say they spent 1,000 hours on homework or something like that. That's a case where you just got to delete out the data like this. The last one I want to show is the influential point. This is trickier because we don't tend to think that we should remove this outlier because it looks so strong. So look at this value right here. That one value is saying that we have a strong, almost a very strong positive linear correlation, but we don't. This is a situation where one outlier called an influential point can actually go and wreck the data set and make it look stronger than it is. So same strategy, you have both, you delete them out, and then it immediately puts it down to a graph. Well, you can see it over here, which is more realistic. This is not a really strong correlation. This is moderate. If you think back to the other ones, you could kind of draw an oval around this. It's a clear between 1/3 and 2/3. It's in that kind of moderate territory, getting up towards the stronger side of moderate, but still moderate. So then when I undo this, you get both again. So let me do that once more, and this time watch your R values. Here I've removed it. They're both 0.63, and that's what it should be. Okay, this should be a moderate relationship because of how spread out most of the data is, but that one value falsely increases the R value, making it much stronger than it is. Then from here, you can read the other answers. It just gives a summary as to how influential point and traditional outliers can go and change that.